Right now, as you read these words, you are surrounded by something you think you know perfectly. Something so familiar that you don't even stop to question it. Light. You think you understand it because you see it, because it illuminates your path, because it allows you to distinguish the colors of the world. But here comes the truth no one tells you. You don't have the slightest idea what light really is. And the most disturbing thing is that the greatest scientists in history didn't know either. Newton was wrong. Young, too. Einstein discovered something so strange that it changed the rules of the game forever. And when Carl Sagan tried to explain it to the world, he revealed a secret so deep, so absolutely bewildering, that most people simply chose not to think about it anymore. For centuries, we lived with a comfortable lie. We believed that the world was out there, solid, defined, real, independent of us. But it turns out that every time you turn on a lamp, every time you look at the sky, every time you open your eyes in the morning, you are witnessing the clearest proof that all of that is false. Light is neither a particle nor a wave. It is something far more disturbing. It is a phenomenon that does not exist in a defined way until you observe it. Yes, you read that right. Reality is created when you look at it. Isaac Newton was convinced that light was made of tiny particles traveling in straight lines. When light passes through a prism, it separates into all the colors of the rainbow. Newton discovered something fundamental. Those colors are not created in the prism. They are already there, hidden in white light. The prism simply separates them, as if uncovering a secret that was always present. And for more than 100 years, the world believed him. Until Thomas Young appeared with an experiment so simple, so elegant, that it completely destroyed Newton's theory. Young took a light source and passed it through two very narrow slits. Then he observed the pattern that formed on a screen behind them. If light were made of particles, you would expect to see two bright bands on the screen. But that's not what happened. Instead of two bands, a pattern of multiple alternating bright and dark lines appeared. An interference pattern. Exactly the same one that forms when you throw two stones into a pond and the waves collide. Young had just demonstrated that light was a wave, and the scientific world had to accept it. For decades, the wave theory of light dominated physics. But then the 20th century arrived. Albert Einstein explained the photoelectric effect, a strange phenomenon in which light can eject electrons from a metal. Experiments showed something peculiar. No matter how intense the light was, if its frequency was too low, it would not eject any electrons. But if you increase the frequency, even with weak intensity, the electrons would fly out. Einstein realized something revolutionary. Light arrived in packets of energy, photons, discrete particles of light, and there was the devastating problem. Young had shown that light was a wave. Einstein had just shown that light was a particle. Both had flawless experiments. Both were right, and that was completely impossible according to classical logic. So physicists decided to test this madness. They took the double-slit experiment and modified it to send only one photon at a time. If light were really a particle, that single photon should pass through one of the two slits and hit the screen at a single point. But when they ran the experiment, something happened that still keeps physicists awake at night. The single photon created an interference pattern, as if each individual photon were interfering with itself, as if that single photon were passing through both slits at the same time. Then scientists decided to observe which slit the photon actually passed through. They placed detectors at each slit. And this is where reality becomes truly terrifying. The moment they added the detectors, the interference pattern disappeared completely. When they observed, the photon behaved like a particle. When they didn't observe, It behaved like a wave. The simple act of measuring, of observing, changed the outcome of the experiment. The photon is not in one place or the other before you measure it. It literally does not have a defined position. It exists in a state of quantum superposition. It is in both places at the same time. It is a cloud of probabilities. And only when you interact with it, when you measure it, that cloud collapses into a defined reality. Observation creates the result. It does not reveal it. It creates it. And here comes Carl Sagan with an explanation that melts your brain. Sagan described Richard Feynman's path integral formulation. According to Feynman, when a photon travels from point A to point B, it does not take a single path. It takes all possible paths at the same time. Absolutely all of them. Straight paths, curved paths, paths that loop around the entire universe before reaching their destination. Each possible path has an associated probability. Most cancel each other out, but some reinforce each other. And the final result is what we observe. Carl Sagan used to explain this with a devastating analogy. Imagine you want to go from your home to work. In the classical world, you choose one route and follow it. But in the quantum world, you leave your house and simultaneously take all possible routes at the same time. You go on the highway, through side streets, around the world, into space. All those versions of you exist simultaneously until you arrive at work. And at that moment, they all collapse into a single reality. But before arriving, there was no single true route. There were infinite, overlapping routes. The implications of this are so deep that most people simply refuse to think about them. Because if light works in such an absolutely strange way, then what else in the universe is lying about its true nature? Everything. The answer is everything. Electrons too, atoms too, molecules too. Everything at the quantum level exists in superposition until it is observed. Reality is not solid. It is blurry. It is probabilistic. It is a field of possibilities that only solidifies when you interact with it. And this brings us to the most important truth. Without quantum mechanics, there would be no modern technology. Lasers, the LEDs lighting your screen right now, the transistors that form the basis of every computer, solar panels. Everything works because we understand the quantum nature of light. Without quantum mechanics, there would also be no stable chemistry. Atoms could not exist. Every atom in your body exists because quantum mechanics allows it to exist. You are a quantum object. A pattern of probabilities collapsed into a form that can ask what it really is. Carl Sagan understood something profound about this. Quantum mechanics does not give us comfort or absolute certainty, but it gives us something far more valuable. It gives us the truth. And the truth is this: the universe is stranger, more mysterious, more astonishing than any human mind could have imagined. We can understand it mathematically. We can predict it with astonishing precision. But we cannot fully visualize it, because our intuition evolved to survive in a world of medium-sized objects. Not to understand the quantum realm where particles are waves, and waves are particles, and nothing has defined properties until you measure it. So the next time you turn on a light, look at the sky, see a ray of sunlight passing through a window. Remember this: you are not just seeing something that illuminates. You are witnessing a quantum phenomenon that exists in superposition, that takes all possible paths, that has no defined properties until you interact with it. You are observing living proof that the universe is participatory. That observation creates reality. And that you, the observer, are not a passive spectator of the cosmos. You are an active part of its continuous creation. Because understanding light is not just physics. It is being amazed at what we really are. And that is what makes light truly extraordinary. It doesn't just illuminate the world, it reveals that the world is an active, dynamic, deeply strange mystery, and that we are an inseparable part of that mystery. If you made it to the end, comment, "I've arrived," and I will personally reply. And if it resonated with you, subscribe to be part of it and give it a like if you enjoyed it.